Welcome to our channel, dear viewers. Today, we embark on a journey through time, a voyage of botanical discovery to uncover the secrets of a vanished world. Our planet has been home to an astonishing diversity of plant life, a tapestry woven over millions of years. Join me, if you will, as we delve into the fascinating world of extinct plant species. These are the plants that once flourished, their roots reaching deep into the very bedrock of our planet's history. Stay tuned to discover 10 plants that once thrived on our planet but are now lost to history, their presence lingering only in the fossil record. Our journey begins in the sun-drenched lands of ancient Cyrenaica, a region in present-day Libya where a plant known as Silphium once thrived. This mysterious herb, resembling a giant fennel plant, was highly prized by the ancient Greeks and Romans. Its resin, said to have possessed potent medicinal properties, was used to treat a variety of ailments, from stomach disorders to contraception. Silphium was so sought after that it became a symbol of Cyrene itself, its image appearing on coins and mosaics. The plant grew wild, flourishing in the coastal regions, and for centuries it brought prosperity to the region. But the demand for Silphium proved to be its downfall. Overharvesting, combined with the inability to cultivate it successfully, led to its gradual decline. Despite attempts to protect it, Silphium vanished from the face of the earth, leaving behind a legacy shrouded in mystery. Today, only fragments of its story remain, preserved in ancient texts and the occasional fossilized seed. Our next destination takes us to the southeastern United States, to the banks of the Altamaha River in Georgia. It was here in the 1760s that two botanists, John and William Bartram, stumbled upon a most peculiar and beautiful tree. Its delicate white flowers, resembling camellias, stood out against the backdrop of the riverine forest. They named it Franklinia Altamaha in honor of their friend, Benjamin Franklin. The discovery of the Franklinia caused a sensation in the botanical world. Its elegant blooms and unusual foliage made it a highly sought-after addition to gardens and collections. However, the Franklinia proved to be a fickle species, difficult to cultivate and propagate. By the early 19th century, the Franklinia had vanished from its native habitat. Today, the Franklinia exists only in cultivation, a testament to the dedication of plant enthusiasts who have kept it from disappearing entirely. Let us now journey back in time, far beyond the realm of human history to the Carboniferous period, some 300 million years ago. During this era, vast swamp forests covered much of the Earth's landmass. Among these arboreal giants were the Lepidodendron, also known as scale trees. These towering plants could reach heights of over 100 feet, their trunks covered in a distinctive pattern of diamond-shaped scars, remnants of their fallen leaves. Unlike modern trees, Lepidodendron reproduced through spores, not seeds, and their internal structure was more akin to that of herbs than woody plants. These giants of the Carboniferous played a crucial role in shaping the Earth's atmosphere as we know it today. As the climate changed and the swamps dried up, these giants of the past gradually disappeared, leaving behind only fossilized remnants of their former glory. Chapter 4, Calamites, ancient relatives of modern horsetails. In the understory of the Carboniferous forests, beneath the towering Lepidodendron, grew another group of fascinating plants, the Calamites. These ancient relatives of modern horsetails shared the swampy habitat with their larger counterparts, forming dense thickets that provided shelter for a variety of creatures. Calamites, like Lepidodendron, reproduced through spores and possessed a hollow, segmented stem structure. However, unlike their towering neighbors, Calamites rarely exceeded heights of 30 feet. These ancient plants played a vital role in the ecosystem, providing food and shelter for a variety of insects and amphibians. Their fossilized remains offer us a glimpse into the intricate web of life that existed during this distant era. Chapter 5, Glossopteris, a botanical enigma of the Southern Hemisphere. Our journey now takes us to the Southern Hemisphere, to the supercontinent of Gondwana, which once encompassed South America, Africa, Australia, Antarctica, and India. It was here, during the Permian period, that a unique group of seed ferns known as Glossopteris flourished. Glossopteris fossils are characterized by their distinctive tongue-shaped leaves, which often bear a prominent midrib. The widespread distribution of Glossopteris fossils across multiple continents provided crucial evidence for the theory of continental drift. However, the Glossopteris, like so many other ancient plants, eventually succumbed to extinction. The Permian-Triassic extinction event, the most severe mass extinction in Earth's history, wiped out a staggering percentage of plant and animal life, including the Glossopteris. Chapter 6: Cooksonia, Pioneers of a Greener Earth. Our exploration of extinct plants takes us back to the Silurian period, over 400 million years ago, to a time when life on land was just beginning to take hold. Among these pioneers of a greener Earth were the Cooksonia, a group of small, simple plants that represent the earliest known vascular land plants. Cooksonia lacked leaves and roots as we know them today, possessing only thin, branching stems that terminated in spore-bearing structures. These humble plants played a crucial role in the evolution of life on land. While Cooksonia themselves are long extinct, their legacy lives on in the diversity of plant life that we see around us today. Every tree, every flower, every blade of grass owes its existence to these early pioneers of the plant kingdom. Chapter 7: Archifructus, a glimpse into the dawn of flowering plants. Our journey now takes us to the early Cretaceous period, a time of great change and diversification in the plant kingdom. One of the earliest known flowering plants is Archifructus, a genus of aquatic plants discovered in China. Fossils of Archifructus reveal a plant with slender stems, feathery leaves, and small, inconspicuous flowers. The evolution of flowering plants marked a turning point in the history of life on Earth. Archifructus provides us with a glimpse into this pivotal moment in evolutionary history, a time when the world was on the cusp of a botanical revolution. Our exploration of extinct plants now takes us to the Mesozoic era, the age of dinosaurs. During this time, a group of seed plants known as Benedetales flourished alongside their reptilian contemporaries. Benedetales were characterized by their distinctive flower-like reproductive structures, which bore a striking resemblance to the flowers of some modern angiosperms. This resemblance, however, is a case of convergent evolution, where two unrelated groups evolved similar features in response to similar environmental pressures. Despite their success, the Benedetales, along with the dinosaurs, met their demise at the end of the Cretaceous period. The reasons for their extinction remain a mystery, though it is likely that they fell victim to the same environmental catastrophe that wiped out the dinosaurs. Our journey through time now takes us back to the Devonian period, a time of significant evolutionary innovation in the plant world. One such tree was Archaeopteris, a genus of plants that possessed features of both ferns and trees. Like ferns, Archaeopteris reproduced through spores, but it also possessed woody trunks and branches like modern trees. Archaeopteris is considered to be a transitional fossil, a link between the more primitive spore-bearing plants and the seed-bearing plants that would later come to dominate the land. Its discovery provided crucial evidence for the evolutionary history of trees and helped to unravel the complex relationships between different plant groups. Imagine standing beneath the canopy of an Archaeopteris forest, the air thick with the smell of damp earth and the sound of the wind rustling through its fern-like fronds. Our final destination takes us to the remote island of St. Helena in the South Atlantic Ocean. Among the island's endemic plants was the St. Helena olive, a small tree with fragrant flowers and olive-like fruits. This species was last seen in the wild in 1994 and is now considered to be extinct in its natural habitat. The extinction of the St. Helena olive is a poignant reminder of the fragility of island ecosystems and the devastating impact of human activities on biodiversity. Habitat loss, introduced species, and climate change are all contributing to an alarming rate of extinction worldwide. By learning from the past, we can make more informed decisions about the future and strive to create a world where both humanity and nature can thrive. As we conclude our journey through the annals of botanical history, we are left with a profound sense of wonder and a touch of melancholy. The extinct plants we have encountered are but a small fraction of the countless species that have graced our planet over millions of years. Their stories, though often fragmented and incomplete, offer us a glimpse into the intricate tapestry of life that has unfolded on Earth. If you enjoyed this journey through time, don't forget to like, comment, and subscribe to our channel for more explorations of the natural world. Let us know in the comments which